Hello, this is the video for assignment 3 plugins. In this video, I will show my implementation of the BlueNoise generator. First, I will show my implementation of the actors, the blueprint actors, and then the source code. And next, I will demonstrate in the view of how it looks like in the game editor. First, let's say the random placement. This is a default noise generator that places random points in a square. It takes 3 basic steps. The first step is to set random stream seed with random stream and a seed. The next step is a for loop based on the seed and the number of points to generate and weigh into the loop body. In this loop body, we query for each point, we query 2 values from the random stream. The random float in range from stream between 0 and 100. And we call it twice and pass the vector 2D into add instance function. In the add instance function, we also pass in the instance static mesh. In this way, it can efficiently use just one static mesh and place them all in the square efficiently. And the next is my BlueNoise placement implementation. In this actor, it basically does the same thing, but it differs in 2 ways. The first, it set a 2D BlueNoise stream seed instead. The second part is in the for loop. For adding one instance at a random location, it directly generate a 2D point from the random vector 2D in between 0 and 1 from a string and pass it to the add instance, and then the logic is the same to the random placement. Okay, this is my actor implementations. So the basically works perfectly. Next, I will show the code I have implemented for the Mitchell's best candidate algorithm. Wait a second, I'll browse into the source directory. Assignment 3, plugins, BlueNoise generator, source, private. Okay, we're here. So I have implemented 2 functions, the seed BlueNoise 2D seed, and the second is random vector 2D. The first function, what it does is to initialize the seed and reset the cache locations and create a new progressive KD tree. And because I'm doing the graduate level part, I need to create something to accelerate the generation of the BlueNoise so that it performs better than the linear search. And I have implemented a KD tree. However, since our application is a little different, it requires progressively generate the BlueNoise points instead of generate all the points directly. Because of this, I make the KD tree progressive, which works like each time you after querying the distance of your generated points into all the points in the KD tree, you insert it into the tray, and then you keep on looping, and after each core of writing vector 2D, you go just like you query and then insert. So this is the progress of KD trays. Okay, the next will go to the main meat part, the writing vector 2D. Basically, it has 1, 2, 3, 4, 5 steps. The first is to generate a single instance when the CM start. It's here we just directly generate the random points and insert that into the tray. And for the next succeeding course, and we will go to the second branch. And here we generate a lot of candidates. Here is the number of candidates is determined by which time it is generated for. The form is k multiplied by multi-sample factors. And here for the writing points to generate, we're still using the writing stream. And for the next part it is very important that we check that this point does not collide all the points inside the KD tray, because a KD tray normally does not support redundant points or value in each dimension. So if we check that this is a valid one, and we will add it into the candidates until we fill all candidates. So this is generate the k validated candidates, and then the next is find the node that is furthest to the nearest node. This is you just query for each generated points. You query the nearest nodes from the KD tray, and then you calculate the distance, and then until you find the one that is the furthest to all the nearest nodes, and that's done. After that, we need to insert these points into the KD tree so that in the next round we can reuse and make sure that the next point is generated and follows the Blue-Loess distribution. Here, the last step is to return this vector. This is the code for Blue-Loess generation. Okay. So here, I'll show the demo, and then before show the demo, I also want to show that the performance, the effort I've spent for the graduate level class section. Here, I compared the performance of the linear search with my progressive KD tray. Here it's just for nearest labor search, and it is progressively continuous searching. And here, as you can see, this blue bar is the linear search, the runtime, and here the other three colors, the yellow, orange, gray, shows the time for the KD tree. The query of points from the KD tree, orange color, the insert the points in the KD tree, the gray color, and the total time for querying and inserting the points into the tree. And here, as you can see, for example, when we want to insert 50k number of points, or to query 50k number of points for the nearest labor, it takes about 1.322 seconds for linear search, but for the progressive KD tree, it only takes 62.49 milliseconds. It's about 21. It runs faster of a factor of 21. Okay, this is the acceleration architecture. And next, I will shoot play the scene and to show the random placement vs the Blue-Loess placement. Okay, here you can see the random placement is clustered together, but for the blue noise placement, it follows the blue noise distribution. They are not close to each other. Okay, next I will increase the number of points from 30 to 50. As you can see, it's increasing, not overlaps, and we will reduce it. Yes, okay. And then we can change the shade. 7, 9. Okay, that's it. That's the video for assignment 3 plugins, the blue noise generator. Thank you.